Okay, girls, let's talk about prime and composite numbers. So let's do the definition of prime numbers first. So a prime number is a counting number that has exactly two factors, itself and 1. Remember that counting numbers are 1, 2, 3, 4, and so on. And what is it saying? It has exactly two factors that are itself and 1. Remember that when we were doing the factors just before, we were saying that 1 is always a factor of a number because I can divide any number by 1. So 2 divided by 1 is 2. 3 divided by 1 is 3. A million divided by 1, a million. 763 divided by 1, it's 763. So I can divide any number by 1. So those numbers that only has those two factors, 1 and itself, is what we define as a prime number. So let's look at some examples. Let's look at 2. Okay, is a 2 a prime number? So let's start finding the factors for 1. So if I start with 1, I say 1 times 2 is going to be equal to 2. Agree? Can I continue? No, because I have finished here. 1 and 2 are my prime numbers, so 2 is a prime number. Wonderful. Let's do 3. So I start 1 times 3 equals 3. Okay. The next one will be 2. Can I divide 3 by 2? No, I can't. So 3 is another prime number. Wonderful. Let's do another one. Let's do the next number will be 4. So if I start 1 times 4 equals 4. Wonderful. Then I have to check 2. Can I divide 4 by 2? Yes, I can. 2 times 2 equals 4. So this one is not a prime number. Okay? Because this 4 has 3 factors, 1, 2, and 4. So it's not a prime number. Okay, let's keep on going here. Let's go with 5. 5 is a prime number. Yes, I can do 1 times 5 equals 5. And then I can't divide 5 by 2 or by 3 or by 4. So yes, this one is a prime number. Wonderful. So those are the definition of prime numbers. Let's go to our multiplication grid and look up here. So you can see, I can see that 2 and 3, these numbers 2 and 3 are going to be prime numbers. None of these numbers in the middle, agree, are going to be prime numbers, because all the ones that we have in the middle means that they can be divided by 3 times 3 equals 9. So all the numbers that we have here in the middle are not going to be prime numbers. Okay, so how do we call those numbers? Those numbers, we call them composite numbers. And the definition for a composite number, so a composite number is one which has more than 2 factors. So if we look at the example that we had just before here, we had here in green my prime numbers. I only tested 3, but I found that 4 was a composite number because it has more than 2 factors. Okay? So composite numbers is one which has more than 2 factors. I don't like this definition. I think I'm going to prove it. Is a composite number is a whole number which has more than 2 factors. There you go. I prefer that definition there. It's a whole number which has more than 2 factors. Beautiful. Now, let's look at something here. Some of you might have heard the CF of Eratosthenes. Okay, so this, if you haven't seen it before, I recommend that you go into YouTube and you search this, because there are plenty of videos that explain how this works. But basically what they're doing, you can see here, they have all the counting numbers. You can see whether we're starting in 1, we're not starting in 0. And what they do is that they cross out all the numbers that are composite numbers. Having said that, 1, is 1 a composite number? No, it's not. But is it a prime number? No, it's not either. because what is the definition of a prime number? It says here, a prime number is a counting number that has exactly two factors. If I do 1, let's do the special case here. I have 1 times 1 equals 1. I can't do anything else. How many factors does 1 have? Only 1. Only 1 factor. So it doesn't fulfill the definition of a factor. So it's not a factor. It's not a prime number. It's neither a composite because it doesn't have more than 2. So it's a special case. So we cross number 1, and then they're highlighting here and they're saying, okay, 2, we already tested 2, and we know that 2 is a composite, is a prime number. And if 2 is a prime number, then what they do is they say, okay, I'm going to cross out all the multiples of 2. So all the even numbers. So they start here and they say, okay, 4, 6. So they're crossing this one out. 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. They cross all of those ones. Then I say, okay, 3, we tested 3. Yes, 3 is a prime number, so we leave it there. We already have crossed 4, so I don't have to test 4. Then I test 5. Sorry. When I say, okay, 3 is a prime number, then I'm going to cross out all the multiples of 3. So if we look at our here it is. If I look at my multiplication grade, so they take this 3 and they're going to cross like 3, they're going to cross the 6, the 9, and then all of these ones, okay? So 9, 12, 15, 18, 21, they're going to cross all of those ones. So let's do that. So 3, the 6 is already crossed, but I'm going to cross the 9. Then I have to cross the 12, which is already crossed, but that's okay. Then 15, then 18 is already crossed, but I'm going to cross the 21. Then 24, but it's already crossed, so I'm going to cross the 27. And then 30, which is already crossed, but I'm going to cross the 33, and so on. And they keep on going, crossing like that. And then they go and say, okay, the next number that I have to test is 7, and 7 only has 2 factors, so it's a prime number. Wonderful. And then we're going to cross all the multiples of 7. So it will be 14, which is already crossed, 21, which is already crossed, 28 that I haven't crossed, but if I had done all the even, I would have crossed this one, and then 35, and so on. And you can see that's how. Give me 1 sec, Valentina. Give me 1 sec. Give me 1 sec. I'll be there. Give me 1 sec. So you can see here that if you do this, then you get all your prime numbers. So you can watch that video if you want it, but it's something that is useful for you to just remember which ones are primes and which ones are composite numbers. Thank you, girls.